Okay, so I welcome you all in this Math 102 Calculus 2 class. So today the objective of our class is to study the unit 6.5 in chapter number 6 of Calculus 2, and the topic is that what is the average value of a function. So in the last lecture we have seen that how to find the volume uh, when we rotate a certain curve about some axis, and the resulting is the shell, some kind of a shell. So it was a cylindrical shell method that we have described, and we have almost done, and we have taken the review of some of the old exam questions and old papers as well. So this was just a brief review that what we have done in the last lecture. So today we are going to see that if we have given some function values, then what will be the average value of this. So as you can see here, so for example, from your previous knowledge, you know that if you have some kind of values x1, x2 and x3, and if you are asked to find what is the average value, so the average value will be equal to, you just add them and divide by 3. So this will be the average value. But now there is a question that if you have some kind of function values, for example y1 which is equal to f of x1, then y2 which is equal to f of x2, and so on, you can say yn is equal to f of xn, then what will be the average function values? So this is the question. So for example, if you write in mathematical form, uh, we write it like you can say f a v e means y values. This is just to take the average, add them and divide by the number of intervals. And graphically, what you mean that you have x-axis, you have some x-axis here, some points, and then we have function values, and you want to calculate the average. So for the sake of engineering problem, since most of the students are from the engineering department, so for example here in the x direction we have some kind of a time, and for each time during the 24 hours we have here on the y-axis is some temperature during the day. Now the question is that what will be the average temperature of the day? What will be the average temperature? So you can see graphically that they put the line from here in this purple color, I think. So this line suggests that during this from 0 to 24 hour, the temperature, average temperature is little bit below than 5. Okay, the average temperature of the day. So that it depends on the data that the data is collected on which country. But you see here the temperature is very low. So what is the idea? So you have given some t values from 1 to up to 24 hours, and you have calculated like f of x, it is like t of t, temperatures. Okay, so you calculated the temperatures and then you graph them, and you have seen that this is the average value that lies. Now the question is how you will find it. Now what is the mathematical way that how it is computed? Now this is the lecture. Now let us see how it has been done. So the question is in general, uh, what we will do, as I told you, that we will divide the points into some intervals, and then we will see that what is the average value. Okay, so let us start the fun. So for example, you have given y is equal to f of x, okay, and the values is from a to b, then what you will do, you divide the interval on which the function is defined into n subintervals, and each of which means delta x will be b minus a over n. Okay, so since you are interested in finding the average value of the functions, so what you will do, you will add those values, mean function values, you can say f of x1 plus f of xn divided by that n. Okay, so this is like the average value. So now we will simplify and let's see what is the conclusion. Since everything is written here, but I am still trying to convince you that how he has been done. So since n, so from here you can see what will be the n. So n is equal to, just cross multiply, n will be equal to b minus a over delta x. So you replace this value here, f of x1 plus 1 plus f of xn, and divided by b minus a over delta x. Okay, now you know that in mathematics you can write it as 1 over b minus a, and here f of x1 and plus f of x2 plus f of xn, and here delta x will come up here. Okay, and since from the chapter number 5 of the Riemann sum you have seen that you can write it as sum of f of xi's into delta x, and now this is the, you know very well, this is the Riemann sum, and if you take just the limit, means now by taking the limit, so taking the limit, we get that limit n approaches to infinity. Since 1 over b minus a is constant, we can take this out, and sum of f of xi's into delta x, I varies from 1 to infinity, and now it is very clear that this value is actually the definition of the definite integral. So therefore what we conclude that, so this value is equal to 1 over b minus a into a to b of f of x dx, and this is what, this is the average, we write it as AFE. So this is the formula of finding the average value of the function. So you see that we have developed somehow the formula of calculating the average value. Is there any question? Is it clear? Okay, so now the question is this, how we can find you mean the questions, how we will solve the questions. Okay, so to solve the question, we have given this example number 1. He asks us that find the average value of the function f of x is equal to 1 plus x square on the interval -1 to 2. Okay, let us see how to solve it. So for the solution, we have given f of x is equal to 1 plus x square, and we have given the interval -1 to 2. Okay, so for the solution, we know that the average value of the function, so we denote it f a v e, the average value of the function f, and according to the formula it was 1 over b minus a to b f of x dx. So clearly this will be equal to 1 over b means 2 minus -1, and now integration from -1 to 2 of this 1 plus x square dx. Okay, so now the final calculations, which will be 1 over 2 plus 1, 3, and from minus 1, sorry, now we have to integrate. So integration is x plus x cube over 3 from minus 1 to 2, and now you plug the limits. So 1 over 3, so 2 plus 2 to the power 3 will be 8 over 3. This was the first step, minus, and minus 1 over 3, and when you compute, here should I write the final answer? So the final answer, hopefully, it will be 2. So if you want, I can do it from here, from 2 plus, so 6 plus 8, 14. So 1 over 3, 14 over 3, and minus minus plus 4 over 3. So it will be 18 over 3, 3 is a 9, so it will be 2. So I done this calculation on the side. So this is the answer. So the average value, of the function is 2. Okay, so it was a very straightforward thing. Now there is another interesting thing, which is known as the mean value theorem of integrals. So in calculus 1, you have learned that what is the mean value theorem, that if you have given a continuous function on the interval a to b, and continuous and differentiable on the open interval, then there is a constant c in the interval, such that f of c is equal to f of p minus f of a over p minus a. This was the previous mean value theorem, but now we are talking about the integrals regarding integrals, not regarding differentials or derivatives. Okay, what this theorem says, that if f is continuous, so if f is continuous, then there is a number c in this interval such that the function value at that point is equal to the average value. And moreover, the interesting thing is that the area under the curve will be equal to the width f of c, this is the vertical height, into b minus a will be the x length. So it will be some kind of rectangle. So if this is a, this is b, b minus a will be the difference, and this from a to this value will be f of c. So this is what is meant by here. Okay, anyhow, so let us do some kind of geometrical thing. What is actually he want to ask to prove this? So the geometrical interpretation of this mean value theorem is that for positive functions, means the values are positive above the x-axis, there is a number c such that the rectangle with this base and this height has the same area region of the graph from a to b, as I told you. So to be more specific, for example, you have given this graph f of y is equal to f of x. Okay, this is the graph, and now we see, according to mean value theorem, from this point from A to this point B, there is a point C, okay, such that the function value, so this is the value you see in dot, this value is actually your f of c, which is written here. So this is f of c. So this f of c is actually the average value of this function. And now the next question is this: what is the area under the curve? So next question is this: what is the area under the curve? In principle, the area under the curve is this one. In principle, the area under this curve is this one, which I am trying to do in this green color. But here we ask, but But here we know that this is actually the area from A to B of f of x dx. Okay, but we say, but what this theorem says here, what this theorem says here, it is mean a different one. He asks that this area can be calculated as follows, that this area will be equal to f of c into b minus a. Now what is this? So let me draw this. You can see this rectangle here, this rectangle. Now this rectangle is what? Length into width. So you know the area of the rectangle is you can say length into width. So what is length? B minus a, and which is width? F of c. So this area of a rectangle, according to this mean value theorem, is actually equal to the area under this curve. So this is what this mean value theorem for integral says. I hope this is now very much clear. Okay, now to get some more practice regarding this concept, which is the average value of the function. I have put only two questions from the old exams, so that you get more uh, insight how to solve the questions, because in the exam it is the problem solving question. We have seen that what is the idea of calculating the average value. Now we are going to discuss some of the questions and their solution. So for example, this question was asked in the term 201. He asked us if the average value of g of t is this function 2t square minus 6t plus 1 on this interval 0 to a is 5. So if the average value, so he gave us the average value, but he asked us what is a. So the solution is already there, but for the sake of completeness, I will try to do by myself. So what was the formula? You know that here it is G. So let me write it G. So you know G AVE, the average value according to the formula is 1 over B minus A to B, F of, sorry, this should be now G of t dt. So now what you will do, you put these values here, 1 over a minus 0. So b is a and a is 0 here. Okay, so now you have to pay attention. G of t is 3t square minus 6t and plus 1 dt. And now you just compute, and given this value is 5. So this value is 5 is given. So we have left only 3t to the power 3 over 3 minus 6t square over 2 plus t and 0 to a, and you can write 1 over a. This 3 is cancelled out. So a to the power 3 minus 3a square plus a, the rest is 0. Then you divide by a, you will get a square minus 3a plus a. And this is equal to 5. And now you can write it as a square minus 3a. Sorry, this should be 1. So it will be minus 4 is equal to 0. Now you can easily see that the factor will be a square minus 4a plus a minus 4 is equal to 0. So this implies a minus 4 and a plus 1 is equal to 0. So this implies a is equal to 4 and minus 1. So you have to pay attention that it is from 0 to a. So this value is bigger than 0. Okay, otherwise it is meaningless. So hence A must be equal to 4, because A cannot be minus 1 because it starts from 0 to something. So what is the A option? This is the option. Is this clear? Any question? Okay, now uh, there is one more question, and I ask you to solve it by yourself, but I give you the idea. This was so. So what is the question? So the question is this: the average value of this over the interval is which one? So I ask you to please do it by yourself. Here the hint is the same: 0 to pi by 3. 3 is sine cube over cos square. Now sine cube will be written as sine x and then sine square x, and then sine square will be written as 1 minus cos square x, and then you have to make a substitution. So here I stop the recording, and then I ask you to solve it by yourself, and let's see you can do it or not. So here I thank you very much.